Okay, so four-dimensional sphere. So, think about how we make a hypercube. We can start with a point, slide it, we get a one-dimensional line, slide it, we get a two-dimensional square, slide it, we get a three-dimensional cube.
Then where do we slide it?
And well, what happens when you slide the three-dimensional cube?
To go in or out.
In the fourth dimension. Yeah, here, it's just sitting right over there. Bring it in. There we go. There's our hypercube. So that's one way of thinking about it. For a sphere, you kind of want to think about it in a slightly different way. And I'll start with a circle and go to a sphere. Okay. So what is the definition of a circle? How do you define a circle?
It's a set of points where in the second dimension all points on the circle are the same distance away from the center of the circle.
Very good. Very good. How about a sphere?
Well, it's the same thing except in the third dimension.
Okay. So how would you say that?
So it's a set of points in the third dimension that's the same distance away from the center of it.
Good. And here, instead of talking about sliding, we can actually kind of think about slicing. So if I have a plane that passes like all the way down here, does it go through the sphere?
No.
No. And what happens when I come up to the sphere?
Well, you first get like a point,
Yeah.
and then a very small circle,
Uh-huh.
and then the circle is increasing width until you get to the biggest circle,
Which is called what?
the diameter. Well, it's the circle that's the diameter.
It actually has a name.
Hmm.
You know, there's some place on the Earth, there's something
The
on
equator of
the
it.
equator, yeah, you could call it the equator.
And then the circles shrink and then back up to a point.
Very good. So you can imagine a two-dimensional plane passing through, and I get nothing, then a point. After the point comes gradually increasing in size circles, and then it goes back down to a point, and then nothing. Okay? So what I would want to do to understand a four-dimensional sphere is do the same thing, but instead of cutting it with a plane, what do you think I'm going to cut it with?
A space.
Yeah, three-dimensional space. So what's going to happen when my three-dimensional space that I'm slicing with is far away from our sphere?
Nothing.
Nothing. And then what happens when I just touch it?
You get a point.
Yeah, so it would, instead of being like a circle in a plane, it would just be like we had a point magically appearing like right here. Okay? And then as I moved my three-dimensional space up, what would happen?
You would get a sphere, then you get increasingly bigger spheres.
Yeah, as I cut through it, the spheres would get bigger and bigger and bigger until I got to a maximal size sphere.
And then shrink.
And those would shrink
Back
all the way
to a
down.
point.
And how do you think you would define a four-dimensional sphere?
Well, it's a set of points in the fourth dimension that are the same distance away from a certain point.
Yeah, and how do you figure out, by the way, do you even think, like, pretend this was four dimensions, and this was like, how do I figure out how far away things are from each other in four dimensions?
I guess you can't use a ruler.
Well, probably not. I don't know. But what math do you think you use? Because I mean, 2 points are going to be connected by a line, no matter what dimension you're in. I guess except for 0 dimensions. So how do you think I measure the distance along that line? What do I do? Or what math am I going to need to use?
Well, probably geometry.
Okay. Specifically, what in geometry is going to help us measure distance?
Well, like just measure this?
Yeah, determine how far it is. So what would we do in a plane? What would we do to figure out how far away at this point, if we called it the origin, was to this point?
We could find the slope of this line.
Okay, how would that help us?
Well, if you find the slope, let's say it has a slope of, well, the slope is how far how far you go over, you go up a certain amount.
Uh-huh.
So let's say this is 0, 0.
Uh-huh.
And then
Just say whatever this is, whatever, pick any number.
let's say it's 5, 5.
Okay.
So you go over 5 and up 5.
Okay, and then how's that going to help us find the distance?
And then you can use the Pythagorean theorem.
Interesting. All right, so now how do you think we're going to label a point in 4 dimensions?
Well, probably you're going to have 4 coordinates.
Okay, so pick them.
5, 5, 5, 5.
5, 5, 5, 5, okay. What am I going to do here?
You need to probably use the Pythagorean theorem for a hypertetrahedron.
Okay. What do you think that's going to say if I called this c? What do you think c squared is equal to?
Well,
for our point here.
a squared plus b squared plus d squared maybe? You have more. You're going to have more than 2 of these.
Oh, good. So you're right. Maybe I shouldn't call this c. Let me call it m.
So you have like a, b, and then... But how many sides would you even have?
Yeah, interesting, huh?
Yeah.
Okay, well, tell you what. Why don't we leave that as a little bit of a puzzle, since we weren't planning on talking about that anyway. And well, someday we'll talk about how you might measure distance in 4 dimensions, because it's kind of cool. Good work today, huh?